Welcome to clickmyproject.com.
Now we discuss about the process of DTC scheme for 4-switch inverter-fed induction motor eliminating the 6-switch inverter operation. The torque control in the recent technique for doing the variable operation in industrial work like jacking, inching, lifting, etc. The different process, the motor at different speed and power. The speed and power is performed by control the torque in motor. This paper proposes design and simulation of direct torque controlled induction motor drive system based on the 3-base 6-switch inverter. Direct torque control is control technique used in AC drive systems to obtain high performance torque control. The principle is based on the simultaneously decoupling the stator flux and electromagnetic torque. A novel direct torque control strategy of induction motor drives fed by a 4-switch 3-base inverter. The introduced strategy is based on the elimination of the operation of conventional 6-switch 3-base inverter. This has been achieved thanks to suitable combination of the 4 unbalanced voltage vectors instinctively generated by the 4-switch 3-base inverter, leading to the synthesis of 6 balanced voltage vector of 6-switch 3-base inverter. This approach has been adopted in the design of the vector selection table of the proposed DTC strategy, which considered a subdivision of Clark panel into the 6 vector. In recent years, direct torque control strategy of induction motor drive has been widely implemented in industrial variable speed application introduced the middle of 1980s. The first DTC strategy involves a simple control scheme which makes it possible rapid real-time implementation. Since then, several investigations carried out in order to improve the performance of the original DTC strategy. The major focused feature are the uncontrolled switching frequency of the inverter and the high torque ripple resulting from the use of flux and torque hysteresis control. Now it is the flow diagram for our proposed work. Here the source will be used. The source is the 3-base AC source and it is getting from the grid. This 3-base AC source will be go to the rectifier for converted to the DC output. The DC output will be going to the inverter. That inverter will be the 6-switch 3-base inverter. The inverter will be controlled using the pulse width modulation. The pulse width modulation will be controlled by the controller and the 6 vector of control technique. The controller will be used the PI controller, and then the control will be controlled by the output sample of error signals. The error will be calculated by the output sample and also the reference signal, and that samples will be getting from the induction motor. The inverter, the DC current will be converted to the 3-base AC also, and that 3-base AC will be control the induction motor here. Here the samples will be used by getting the result of frequency of the induction motor, and that frequency will be controlled BWM with generated the switching pulse. The switching pulse will be going to control the inverter by using the AC pulse with the specific frequency of reference torque, and it will be control the induction motor torque by using the user defined, and it will be help to the industrial application for getting the better result. Now we going to demo of our process. In our process, first we use the 3-base AC source for the input. The source will be connected to the rectifier. The rectifier will convert the AC source into DC source. The AC source will be acting here as a grid connection. That DC will be converted to the by rectifier. The DC will be going to the measurement of DC voltage. The DC is the input of the DTC process. The DC will be go to the DC to AC inverter. The AC in that inverter will be controlled by using the BWM. The BWM will be controlled by using the control signals. Now after the inverter, the 3-base AC source will be connected to the measurement port. After the measurement port, it will be go to contact the induction motor. Now we get the reference signal from during the measurement port, and it will be fine to calculate the voltage and current of induction motor connector, and that it will be connected to the control DTC control schemes. In this process, we will give the torque and the flux of the induction motor, and the voltage and the current of the induction motor will be given, and that torque and the flux will be coming from the controller signal. In the controller signal, we will give the reference torque and also getting the torque from the output of the motor, and it will be generated the flux and the torque based on the controller signals. The flux and torque controller by using the PI controller technique. After the PI controller, it will be generated the torque and flux based on the reference torque and also the output track of the induction motor, and the torque and the flux and the output and the voltage and the current will be coming to the controller signals. Here the 4 input will be going to the torque flux calculator and also the flux sector seeker under the switching table. The torque and flux will be going to the flux and torque hysteresis. It will be find out the frequency of the induction motor by the specific region frequency of inverter, and the current and voltage will be find out the normal torque of and the flux will be calculated, and the flux angle will be find out. The flux selector seeker will be generated the 6 phase vector for generating the pulses. The pulses will be generating by using the switching table. In the switching table, we will find the base angle and the torque of the base and the estimated flux, and the 6 base switching vector will be used. And using the 4 inputs, the switching table will be generated the head pulses. That head pulses will be going to the inverter side. That inverter will be control that inverter switches. That pulse control the inverter switches, and that switches will be control the inverter, and it will be generate the 3-phase AC source with a specific frequency of control the torque of the induction motor. Now the induction motor will be controlled by reference signals of input specific torque control. Thank you.